Hi, today we're going to look at reflections, and actually there are four reflections going on already in this starting slide. We've got the title, which has been reflected in a mirror line. It's kind of as if it's reflected in some water, I suppose. Actually, we do then have a proper mountain reflected in some water. We've got a person reflected in a mirror. They're kind of like looking at themselves, and then we've got a mirror line with a car as well. It's quite interesting when you look in the mirror. If you put like a side parting to the right on for your hair, then when you look in the mirror, you'll see that the reflection actually has a side parting to the left. You get this mirror image, so you don't actually quite see what you look like. You see this mirror image, and it will look slightly different. How everyone else sees you will be slightly different. When I talk about reflections here, I'm not talking about, say, some light reflecting off of something and coming back. I'm actually talking about, I suppose, what if I had a mirror, what would the objects look like in the mirror? So we're going to have these mirror lines, and we're going to be going through the mirror line to in order to draw the reflection. So just to distinguish that, because reflect sometimes also means reflecting off of a surface. All right, here's another couple of images of reflections. Bruce Lee in one of his films. I've forgotten which one this is actually. I should remember. There's a famous scene at the end with a hall of mirrors, and then we got these like these funny mirrors where you get sort of have a curved mirror, and it ends up like your arms might look really, really long. We're not going to be doing any of that. We're going to look at a sort of a straightforward mirror, and the mirror line is going to be shown by this dotted line, and then we're going to try and draw the reflection in it. And to do this, we make a perpendicular with the mirror line and travel along it. So let me just demonstrate what I mean by that. I mean that I might pick a point, and then the perpendicular means the line that is at right angles to the mirror line. So I'm going to travel along it this way, and here's my right angle. Once I got to the mirror line, I travel the same distance away, because when you look into a mirror, the person you're looking back at is essentially the same distance away from the mirror as you are. So imagine shapes looking in a mirror. This would be what would happen. So we've gone along 4. I'm going to go along another 4, and that point's going to end up there. That's my reflected point. So to do it for the shape, I just do it for all the corners, and then I can create my my reflected shape. So this one I'm going along 5. So keep going, and there we have it. I've got all my corners, and I can join things up to create my reflected shape. There we go. So have a go at this one. This one's like, I know it's slightly different because the shape's actually through the mirror line, but just go with what I said and see if you can get the reflection. This is a bit strange, I know, because you don't, like when you look in the mirror, you're not like halfway in the mirror with your arm or anything. This is what's happening here, but the principle still does work. So try and apply it in this scenario. Okay, I'm going to have a go. I'm just going to pick each point in turn. So the top, I'm going along 2, going to go along another 2. If I put the next one down, I'm going along 4 at right angles, going to go along another 4. And then finally, this bottom point, actually I'm going back the other way, and I'm going to end up over here. And in this particular case, I might do it in purple actually, we're going to end up with this overlapping shape. That's absolutely fine. Okay, that is the mirror image. You can see that we sometimes call this like a line of symmetry as well, like because they're symmetrical about it. Okay, that's you can get vertical mirror lines. You could get a horizontal mirror line. It would be very similar. I mean, we could imagine if I took this and rotated it and asked you to reflect it, you do exactly the same thing, but you'd be going at the perpendicular, which should now be vertical. I'm just going to take a look at another type of mirror line though, and that is a diagonal one. And we're going to do it when we're going to keep the line diagonal, and we're going to draw the perpendicular from there. But I will talk a little bit more about that at the end. But it is the same idea. So I'm going to take each point, and I'm going to go towards the mirror line. Now this time it's going to be diagonal. So it's going to be here. That will make a right angle. And I've gone 1.5. So if I go 1.5 again, it's going to end up there. This point, I'm just going a half, so it ends up like so. This one, I'm going 1, 2, 2.5. So if I go 2.5 again, it ends up there. Good idea, I think, for reflections is don't just do one point and then try and guess the shape, because I think it's very easy to make a mistake. You can probably see where this one's going to go now. I reckon it's going to go there, but you know, get most of them down. Don't rush it. You can get away with it for some other transformations, but I'd say not. Don't do it for reflections. Let's do it in full anyway. So 1, 2, 3.5 diagonally, that is. So then a half, 1.5, 2.5, 3.5. Yes, it does work, and we get this rectangle here. It seems to have changed orientation, and that's because it's a diagonal line. You know, hopefully you can see that it is definitely symmetrical. And if you were to, this is one way of kind of cheating at this. If you'd made it a vertical line, like you turned your paper, it's maybe a bit easier to see because actually it's exactly the same as what we did before. But you know, I'm going to do it with the mirror line diagonal. I'm just going to apply the same principle as before. So I'll put that back as it was actually. Have a go at this last one. Very similar question. Obviously you could have the diagonal going the other way, but it's the same kind of idea. So try this for the triangle. All right, this point here, go along half. So I'm going to go along another half. Just take each point in turn. I'll go this one now. So 2, 3. So 1, 2, 3 diagonally. Yeah, and it's quite hard. Where's that triangle going to form? I don't think it's worth rushing it. Let's do it properly. So 1, 2, 3, 4. 1, 2, 3, 4. Maybe you would have realized it was going to be there. And I got my shape. I do need to draw in my shape. So I do the points to make things clear, but actually it is the whole shape that I'm reflecting in the mirror line. Okay, over to you then. So here are a load of shapes. Here are a load of mirror lines. In some cases, you might need to extend them. Not quite sure. See how it goes. But take each one, reflect it in the mirror line, and see what happens. If you're unsure, then I'll do one for you, and then I'll leave you to it. So, okay, I'll go with so for EF, you probably need to extend that mirror line. That is the case. So I think I'll do this one because it's a bit hard to reflect this point because I can't see the mirror line. So let me just extend it very slightly. It's going to go on forever in that direction. Okay, and then if I pick this point, I'm going to go a half, and then that point's going to end up there. Done. If I do this point, I go 1, and then another 1, so it's going to end up there. Here, I go 1.5, so it ends up there. And I can see the other one's going to end up there now. And I've reflected my shape. Let me do it. Actually, let me draw it as a block. Okay, so there's my shape. I've reflected the first one, and maybe I just put a little tick by it to show that I've done it. So I want you to carry on with all of the other ones. I'll pause the video, try this, and in about 10 seconds I'm going to show you the answer. Okay, I really like this topic because it's great to just make lots of self-checking exercises where it actually makes words. So this is what you should have got, the word image coming out. And if you kind of, you can kind of maybe spot if you make a mistake, like if somehow this one ends up over here, you can just go back and check it. So if you are good with that, then that is absolutely fantastic. There's one extra little bit we're going to do. So just check you're happy with this, and then we'll move on to the next bit. Before we move on to the last little part of this lesson, I'm just going to recap equations of lines. So is the equation of this blue horizontal line A, B, C, or D? Well, the answer is B. And if we can see why, because this here, the coordinate would be 3 minus 3. Whereas, say, over here, it would be -1, -3. All the way along, we have that y is equal to -3. This one, no multiple choice. Can you use what we just did in the last question to write down the equation of this line? For this one, it's x equals 3. So if it's a y equals, it's a horizontal line. If it's x equals, it's a vertical line. But how about this one? What's the equation of this line? Similar sort of thing, but now it's going through 0, 0. Actually, everywhere along this line, x is equal to 0. Sometimes this is referred to as the y-axis, so just be aware these are exactly the same thing. Meanwhile, if you had the x-axis, that can be referred to as this horizontal line here. That would be where y is equal to 0. And finally, this is another really classic graph that you're expected to know. What's the graph of y equals x? Remember, everywhere along this line, y and x are going to take exactly the same value. So look, you can immediately see it's not going to work here because this is 4, 0. They're not the same. They are, however, the same here because we've got 1, 1, 2, 2, all the points in between, 0.9, 0.9, and so on. So it is this one. But what are the equations of the others? Just a little extension. Well, this one is another one that you need to be aware of. And y and x have the same value here, except that the other one is the negative of the other one. So this is y equals minus x. That's an equation that you need to, a graph that you need to know. And this one here, it's like y equals x, but we've moved it up. This is actually y equals x plus 1. So here goes this final, it's not the final task, but another task. Let's say, can you try reflecting now if I give you the shape and I give you the mirror line as an equation? If you finish this, you might want to try and make it your own puzzle. Okay, I'm just going to show you the answer to this. This is what happens. I've drawn x equals 2, y equals -2, and etc. There's orange lines. And I've done all the reflections, and you end up with this smiley face. So you can be sure you got it right if you got this face. So either now, if you've done this, then you've shown that you can reflect through given lines. Brilliant. Horizontal, vertical, diagonal. Just take care as you do it. Make your own puzzle. One final task that you might be interested in if you've done that. When I say make your own puzzle, start out with a shape. Don't make it too complicated. And then, basically when I did this puzzle, I started out with the face. I decided on the mirror lines, I did the reflections, and then, for example, I decided for this one I was going to reflect it in x equals 2. Sorry, actually it would be it would be this one, and then it ended up over there. So I kind of then rubbed that out, and that became the start of my puzzle. So it's quite an interesting thing because it makes you think about the problem in reverse. One final task you could do is you could take your name, or maybe even another, maybe you could try and actually draw an object that's not mathematical. I don't know, just sketch something and see if you can reflect that in a mirror line and do your best to make it as accurate as possible. That could look really good.